Yeah, my name's Tom Ellert von Brasch, working for the Norwegian National Mapping Authority, Hydrographic. What I'm going to talk about today is about data flow and data flow infrastructures, using the example of the Norwegian Hydrographic case study. I'm going to keep it at a fairly high level. I've only got 20 minutes, so I can't go down right to the bottom level. But really I want to talk about the movement from nationally standardized data to the Inspire data model. At the moment, there's a lot of data sets out there. I think we saw before there are over 13,000 data sets available at the moment, but these are towards the national standards. And it's the movement of this data to the Inspire model that we'll be looking at. So, looking at a really high level, Inspire data availability. As you can see, what we're looking for is to get the data out of the databases and available to the end user. And ideally, in the future, what we're looking for is the data to be in Inspire format. At the moment, when it comes to making the data available for the NMCAs, what you're looking at is two main options. The first is to collect a completely new data set and make that available, and that should be done, in theory, by this year. The alternative, which I think most NMCAs are going to be looking at, is the restructuring of existing data sets and existing data models. As you can see, this only has to be made available by 2017. Now, it's quite a long way in the future, quite a long way in the distant future, really. But as I'll show you, the process for the data movement is quite a complex one. So to begin to think about it early on, especially considering the number of organizations that will be involved in the process, especially with the Annex 3 data specs coming online, it's very important to start this process early, I think. Start off with the challenges. You can really split these up into two groups, technical and organizational. First of all, looking at the technical, the complexity of the data in the data storage models is something you come across pretty much immediately. Especially with the Annex 1 themes, where you have transport networks, hydrography, the kind of heavy themes. You're going to be collecting data from a number of different places, and it's going to be stored in a number of different ways as well. You also have scalability. Now, this is important. What you may come up with a fantastic data flow model, may work beautifully well, but you may have only designed it for data sets of maybe 200-300 records, 1,000 records. You try and scale that to a few million records, and you could find you have problems. So to understand the data sets and the size of the data we're looking at is very important. Understanding the options as well. As I'll show you, there's really a plethora of options available at each stage during the data flow process. And a careful understanding of these and their implications in the whole process is important. On the fly or offline, this is the first major question you'll come across, and this is the one that can actually shape how the infrastructure and data flow process runs. And finally, production and distribution. Should you just keep your data in a distribution, in a production environment, and access it from there, or should you try and provide a more sort of bespoke distribution environment for the network services to connect to? Organizationally, you have the issue, especially with the Annex 1 themes again, of cross-department and inter-organizational processes. Now, as I'll explain and demonstrate with the Norwegian model, there are several organizations involved, and close communication between these will of course be a challenge, especially all the way through the process. In addition, multiple ETL service providers, we're talking extract, transform, load kind of processes with multiple organizations and multiple data sets. You're also talking about multiple data flow processes. Now, they may be handled in-house, great, but there's also a good chance that for the smaller organizations, especially maybe handling the Annex 3 data, they might have to go out-house to organizations. And you might find these kind of processes crossing each other, so communication between these is also critical. And of course, a coherent understanding of issues. We all know how big a beast Inspire is, and the data flow process is just one small part of the whole project, but it has a crucial impact on other areas, for example, network services. So you really need to understand the issues from an early stage to make sure that there's no problems later on. So we'll move on to the sort of general principles. This is obviously starting from a pretty much as higher abstract level as you can possibly get, but it just explains what we're really looking at. We have a somewhere. Yeah. There we go. We have a single data source here. What we want to do is extract that data source. We want to transform it to the target data structure. In this instance, we're looking at the Inspire data specifications, of course, and then load it into your destination data storage, whether that be a production database, distribution database, whatever. So that's the high level, but you don't need to go far before you start adding in levels of complexity to this. This is pretty much just one level down, and here we can see just adding in a couple more data sources. Could be different sources and different organizations, but you already see you increase the number of processes that are involved in the overall data flow. And even with the destination storage, you have to decide and investigate whether that one storage is okay for all of your network services, for your view services and your download services. It's all very well, I mean, the download services, they don't have to worry quite so much about the quality of service requirements that you have for the view services, speed, for example. And that could be some issues that come into the decision about the storage. So moving on to the Norwegian example, I'll just go through this and just show you the kind of questions that pop up in a data flow process and the kind of answers you get as well. The current sort of national standards in Norway mean that there are 4 institutions that hold hydrographic data. You have the Norwegian Water Resources and Energy Directorate, the Polar Institute that holds information about Svalbard, one of the Norwegian regions near the Arctic, the National Mapping Authority, Kartverket, and Gevext, sort of coordination between many institutions obtaining large-scale data. The numbers up here, 4 institutions, 20 databases. Now, if you're extremely lucky, all those 20 databases will be in the same format and be using the same software. Highly, highly unlikely, though. I can certainly name at least 3 or 4 different software that these groups are using. From there, sorry. From there, we obviously want to transform this data and national standard to the Inspire hydrography data specifications here, make that available for the network services, the view services, download, discovery, and transformation. Now, transformation here is kind of straddling the line because it can be created as a service, a separate transformation service, or you can integrate that into your offline data flow process. And that's really what we're going to be talking about a little bit more here. Now you can work. So before we started creating our data flow, we had to get a few facts. It's very important that you get as much information about your data sources as possible, especially if they reside in multiple organizations. So the first to look at is update frequency. Is the data updated continuously? Often, sporadic? We're talking daily, weekly, or a couple of times a year. Are the databases small or heavy? A couple of million records with heavy geometry, or maybe 1,000 records with just light point geometry. And crucially important, we're talking about single database or distributed databases throughout organizations. As I've already said, the Norwegian model has many distributed databases amongst the 4 institutions. And that leads us on to another question here, and that is, where's the data going to reside and where are the services going to reside? There's always this connection between the data and the services, and it's important to look at this interaction and the different options you have. We actually came up with 17 different options about where the data and services can lie, and they pretty much come under 4 major categories. The first option you've got is that the data and services both lay with the data owner. For example, the NMCA holds the data and provides the services. Nice and easy, great. The other option is data sits with the data owner, but the services lay with the Norwegian Mapping Authority. For example, the data could sit with the Polar Institute, but we're creating the services on top of that. Thirdly, the data can sit with the data owner, but the National Mapping Authority might hold a copy, for example. This brings in adding complexity with the update routines and moving the data, etc. And finally, the data could sit with the NMCA, but it could be managed by the data owner through some kind of management client, etc. So these are the questions and facts we had to collect from our own model. The answers we got were the data was updated infrequently, once or twice a year. We're talking about large data sets of millions of records for some of the tables, and as I've already said, distributed systems, many organizations and databases. So from there we have to consider the first major question, which is on-the-fly or offline transformation of the data. If you read the INSPIRE documentation, the guidelines and the other information out there, you'll see there's pretty much three major options you've got. The first is to do on-the-fly transformation. You're holding your data in the national format in the database, and you're letting your network services access that directly and transform it on the fly. For example, a download service can do that. The second option is this offline transformation. Here you've got your data in the national database, you transform that offline at the back end and come up with a INSPIRE database, according or very much like the INSPIRE specifications. And the third option here is this offline, not offline, but separate transformation service that you can provide for people. Which one of these you choose is pretty much dependent on how your data is set up, the organizations involved, the update routines, etc., as I've already said. The ideal scenario is on-the-fly transformation. You keep the data in the production database. There's no kind of separation of distribution production model, and the data is as up-to-date as it possibly can be. But that works only if you're looking at frequently updated data and light data. Transforming 100 records, simple geometry, not really a problem. Trying to transform 1 million records, reference system, attributes, etc., much more of a problem. That's when you're looking at the offline transformation process here. And that's really what we'd be looking at for the Norwegian model. The third option, the transformation service, from our eyes, not exactly ideal. You're adding an extra process. Not only do the clients have to get the data from your system, they then have to send that data through another process to get it back in the INSPIRE format. In addition, you're never quite sure what the user's going to do with that data in the meantime. Ideally nothing, but you're never too sure. So as I said, what we were concentrating on is this offline transformation. Just a note here at the bottom, it's just a link to the GeoNovum website where this diagram actually comes from. Just want to mention an excellent source of information about everything INSPIRE, not just the theory, but a few implementation examples as well. So I thoroughly recommend you visit that one. So here's where we're looking at a INSPIRE database hosted by the NMCA. In theory, you're looking to get your data into this and serve it out through the network services here. As I've already said, there were 3 other institutions involved in our model. And the first institution, we're lucky enough that we already manage their data for them, so we already have their data in our system. Lovely, 50% of the data is already there. Organization 2, they've told us that they want to hold their own and manage the data, but they're happy for us to have a copy. And so we're going to get all of their data as well. But this leads to an extra process of getting the data across from their organization. The third organization said they want to hold and manage their data on their own and not actually have it at the NMCA. In that case, what we're going to be looking at is direct access from the network service. A view service can maybe cascade down to an existing service or connect directly to the data. A download service would probably connect direct. So this is the final situation. We have, let's say, 75% of the data now going to be residing in the NMCA database, with the rest of the data being connected to by the network service. I'll go on to talk a little bit more about this Inspire database, because there's a lot of questions and options around that one. This is a not very simple to understand diagram from the process. I'll go through it as simply as possible. At the bottom here, option number 1, this is where you can have your production database to be the Inspire database. You can connect to that directly from the network services here. The web feature service, for example, can connect direct to that and do the on-the-fly transformation. If that's not possible, and as I've said for the Norwegian model, it's not ideal, you could look at option number 2. Creating database views on top of the production database. This can work very well. It means the data is completely fresh and up to date. You're not creating separate distribution and production environments. But you have to take into account whether that can meet the needs of all the network services. That might work very well for the download services, but the view services, which has to serve out data within at least a request every 1.5 seconds, that may not be fast enough. We all know views aren't exactly speedy, and it could be that's not good enough. In that case, you can look at the actual distribution database. This is where you're moving the data from the production to the distribution environment, creating a whole new database infrastructure and system. The advantage of this is that you can set it up however you want. You can make sure it's completely Inspire compliant, mostly Inspire compliant, and you can tune it to your services. So in a way it works well, and that's probably what we'll be looking at. The 4th option on the right here, again, that's talking about the external transformation service and software. So you can see here the sort of complexity and options you have at every level during the data flow process. And I'll move on back to this diagram. This is where we talk about the data moving from the second organization, or holding and managing the data, to the NMCA. And this extract, transform, load operation here, this is a crucial part of the whole process, and you have numerous different opportunities and software you can use for this, so I won't go into all of them. What I'll do is briefly show you an example from the Dutch, especially using the cadastre information. I'm just showing you this because this is actually in operation. They've created this on the back of Esden and Uraden. And this is one way of exporting and transforming your data. Very quickly it goes from the native data out into XML, GML, nice and verbose. To that you can apply the XSLT scripts, which not only converts the attributes, etc., but also converts the projections and reprojects it. And it also creates insert statements for PostGIS. So you can put it into your distribution database straight away there and access it from the network services. So you can see this is just one way of doing it. There's numerous others, but you can see the amount of steps in this process already. And each one of these steps is going to have further impacts down the line. Finally, conclusions. A few conclusions from the work we've done. If you have large data sets and infrequent updates, you're best to look at offline transformation. It's the safest way and quickest way of doing it, especially when you talk about view services. It's important to obtain as many facts and figures as you can on the source data and the source organizations and infrastructure. Also, you have to consider the impact on the network services. These are the services going to connect, so they need to have a tight interface between them. In general, you can say at the moment there's no single best practice for this. It's obviously a little bit in the future, but there's so many options out there. There's really no right way or wrong way of doing this. There's just the best way according to how your data is stored and managed. Data flow process, it can be different, as we've seen, not just for each data set or theme, but for individual feature types. This adds another level of complexity onto the data flow process. As I've shown, there's a plethora of options at really each stage. And finally, good communication and cooperation between data owners will be crucial to you, especially when you look at the heavy Annex 1 themes, the hydrography and transport networks. And that's the end of the talk. Yeah.
Thank you very much. Do you have any questions? No? now questions again. How long does it take to make that transformation to the Inspire infrastructure for all of the Norwegian hydrographic data?
You mean how long does it actually physically take to move the data or come up with the actual...
No, as a time.
As a time? We haven't actually done the testing on the speed of the system yet. We're still working on the really low level with the software and the exact transformations we're going to make. Setting up the theory is one thing, but actually getting the final software installations and implementations is probably further down the line, sometime next year, I would guess.
All right, okay, thank you very much.